recording started, so we're going to continue the theme from before of testing cases in data sufficiency. And in general, remember that when you look at a data sufficiency problem, as opposed to multiple choice, in multiple choice there are lots and lots and lots of strategies. There's algebra, there's back solving, there's common sense estimation, there's plugging in your own values. There are lots and lots and lots of ways to do multiple choice problems. In data sufficiency, on the other hand, in general, when you have a data sufficiency problem in front of you, there are really only two ways to do it. I mean, these are very broad categories, but basically you're either going to use textbook style things, which, I mean, that's a very broad category, but anything that would be considered traditional approaches. So, you know, algebra, theory, etc. But then if that doesn't work, then basically the only option left on the table is test cases. And what we're going to talk about today is that whole notion of testing cases. So there it is. So this is going to be today's focus. I mean, some of these problems may still be doable algebraically, but the primary focus is on developing this skill. Because especially in higher scoring students, this is one skill that I find is often underdeveloped. You know, and it's sometimes the only thing standing between. If we have a student who already has 47, 48, sometimes it's the only thing standing between that student and a score of 51 on the quant. So it's super important skill. In any case, here's the copyright notice. The practice problems are from the GMAT prep software. They are copyright GMAC, used under fair use doctrine. And when we present you with multiple choice questions, this is where you indicate the answers. So let's do it. Let's pick a problem for you to do. Go ahead and try this problem. I'll give you a timer here, say at 2 minutes and change. Go for it. And remember where your multiple choice answers are found. They are found right there. That's where you find them. Okay, it's data sufficiency, by the way. We do assume a certain degree of familiarity on your part with the answer choices. In other words, we expect you to know what the data sufficiency answer options are. If anybody doesn't know, we can provide them, but for these study halls, we generally assume that you're familiar with the basic functioning of the problems. So there's still a bunch of you who don't have answers indicated, probably 10 of you. So remember, the GMAT is not an exam where you can not answer things. So please pick something that is a something. The answer choices, can we go over the answer choices? Yeah, here, I'll just show them to you. I'll just copy them out of the official guide here. So, we do, I mean, hopefully you know at least what sufficient and not sufficient mean, because that, we can't really cover this on that basic of a level. But provided you understand what sufficient and not sufficient mean, then you can understand these. So. All right, there's the choices. So go ahead and pick A, B, C, D, or E accordingly once those choices show up on your screen. Still a few of you guys. Okay. All right. So let's take a look at this. We're kind of all over the place on this. Here is what people have. I mean, basically people are picking A, B, C, and D. No one has E here, so interesting. Let's take a look. I'm going to refrain from showing group statistics because they don't really illustrate a whole lot. This is the first thing to do with data sufficiency is to figure out what the goal of the problem is. There are actually several of these Thursday study hall programs about this exact idea, but basically the idea is that you need to find what you are actually trying to do with these statements, which perhaps surprisingly a lot of people don't really clarify that step as much as they should. So always figure out your goal first. And that's going to be very different for a problem like this with, what do the answers to this problem look like? The answers to this problem are going to, like, what are the only possible answers to this question? Direct answers. Is this less than that? The answer would either be what or what. It's either yes or no, right? So we've done this in past Thursday sessions, but here's a brief synopsis of what you should do when you're faced with a yes-no question on data sufficiency. What you should do, the first thing you should do is translate yes and no into the specifics of the problem. Like the actual things that are in the problem, so U's and V's and stuff like that. Once you have that, then you should understand your goal. Or first understand what not sufficient and sufficient mean. And then after that, understand your goal, which is always the same goal, but it's still, you got to understand what it is. So in this case, yes and no. I mean, this says, is this left-hand side less than this right-hand side? So if it's a yes, that means the left-hand side is actually less than the right-hand side. So, and if it's not, if it's no, then it isn't. So yes means 1 over u plus v is actually less than 1 over u plus v. And a no answer to this, it just means that that's not true. So what, meaning if it's a no answer, what's the sign in the middle of this inequality? Instead of a less than sign, a no translates as not greater than. Watch it with that. Be careful. Not strictly greater than. It's greater than or equal to. Yeah. So remember, the no would be all the cases that are not a yes. I mean, don't forget that. Don't forget about equal to. So this. I didn't want to copy that one. Let's try that again. Okay, a no thing would be the same inequality, but I need to take that inequality sign and change it to a greater than or equal to sign. So that's what a no means. Because, I mean, the importance of this step, this is a crucial step. Because, I mean, the reason why a lot of people find this stuff hard is because they're still thinking in terms of the word yes and the word no. And it's really important not to think in those terms, because yes and no are not mathematical concepts. Like, you can't do math in a problem and get the word yes or no out of it. So it's super important to translate like this. Because again, yes and no can't emerge from math work. But these things can. I mean, these can be direct results of the work that you do. So the point is this is concrete, yes and no or not. Not sufficient and sufficient always mean the same thing, but you should still clarify it every single time until it becomes an instinct. So not sufficient means what? Someone tell me in the chat box. Not sufficient means that you can, see, maybe is not a goal though. I mean, maybe is not something you can try for. Yeah, that's a concrete outcome. Not sufficient means that you can get yes, you can get both of these things. That's a concrete outcome. Don't say maybe, because you can't try. Again, you have the same problem as you do here. You have stuff that cannot emerge from doing work. You can't do a bunch of math work and have the word maybe pop out of it. It's not a thing. So, and that's what causes difficulty with this, is you don't have a goal that you can actually try for. Sufficient basically means that you fail to get that. Sufficient means you're stuck with just one of those outcomes. And then what your goal is, I mean, just think about what it is that you can try for and not try for. I mean, you can't really try to have something not happen. So this means that the goal that you're going to try for is always going to be not sufficient. So let's give me a goal. So when we test cases quite in general, when we test cases, you're always going to try for not sufficient. So let's take this to the next page where we have some free space. And you want to do this every time, every single time. So there's the question, and then here's the yes and no. And get both is not sufficient. And can't get both is sufficient. All right, that's good. What I like to do, you might think this is overkill, but for each of these two statements, let's go ahead and copy the two statements down here. So here's statement 1, here's statement 2. We can divide the screen up accordingly. I like to actually write both of those out with question marks after them, just so we are absolutely clear on what the goal is. If we can make both of those things happen, then we got not sufficient. Okay. So let's talk about testing cases. And remember, your goal when you test cases is to try to make both of these things happen, guys. Let's test cases. Try to make both things happen. So I mean, one thing you'll learn fast enough here is that when you do test cases, the first case that you plug in can be totally random, as long as it satisfies the conditions. Because any case that is valid will do one of these two things. And then after that point, you can have a more focused goal of doing the other one. So we do need this to be non-zero. We need this to be true, and we need this to be true. So someone give me a case of U and V that actually does all three of these things. This has to be non-zero. So does this. So does this. Someone give me some U. 1 and 2. That works. Okay, so U is 1 and V is 2. All right, let's do it. So let's make columns, U, V, 1 over U plus V, and then 1 over U plus V. If Jose, it might be, I don't know what kind, it looks like you're on some sort of phone, but maybe that fixes it. If not, I don't know. Just switch the screen real quick. But otherwise, okay, I guess I just toggle the screen a little bit. All right, U is 1, V is 2. That'll give us 1/3. And this will give us 1 plus 2. So this is definitely a less than. Once we have that, what is our only goal in life? What are we trying to do? Looks like we're on a little bit of time delay here. Interesting. Let me know if you guys can hear my voice. I think my internet is being uncooperative. Let me know if you guys can hear me okay. Okay, well, someone's hearing something. That's good. So your goal is to make the opposite happen. So Right, because we got this. In other words, we can circle this. So now the only thing, I mean, getting additional cases of this is not going to help us do anything. So we don't want additional cases of this. We want to try for that. So let's try for that. I'm seeing an icon that says you guys are not hearing me. Let me try to just shut up for like 15 seconds and see if that helps. Okay, I think you can all hear me on time now. There's a bunch of icons that I can see when the sound is delayed. All right, we got this. The point is we have this. Getting more of this will not help us do anything. We need to try for that. So that's the thing we try for. We try for this. We try for the greater than or equal to. Does anybody have any idea how we're going to get that? What kind of numbers will give us a fast track to that? And I mean, you might want to, even just randomly, yeah, you might want to try different kinds of numbers than you tried before. So yeah, try negatives or 0 for V. Well, let's see if that works. So let's try, somebody says, I think 1 and -2. So same kinds of numbers, but just switch the signs out. So 1 and -2. So then 1 over u plus, and we still satisfy the conditions. No, we don't. That's because u plus v is not greater than 0. We can try 2 and -1. Okay, so now this 2 plus -1 is 1, which is greater than 0, and also 2 is greater than 0, and this is also true. So 1 over u plus v is 1 over 2 minus 1. So that's 1. And then 1 over u is 1/2 plus v is -1. So 1 is greater than that. So this statement's not sufficient. Solid proof of it right there, because this is greater than or equal to that. Got both. We're done. Not sufficient. And I mean, this is a problem where algebra is really going to be sort of frustrating, because dealing with signs is going to be annoying. I mean, you're not going to have any way of doing this algebraically while accounting for the possible signs of these things. So that's where testing cases is your friend. I mean, especially on things like inequalities and signs. You would have to break this up into a million zillion cases if you were going to do algebra. All right, let's try statement 2. So A and B are gone here. So we do statement 2. So we need to have this and this. And I mean, if u and v are both positive, then this will always be true. So we don't really need to worry about that separately. So according to that condition there, we know now that u and v are both positive. Sure. Well, let's try. So we're not going to be able to pull the same kind of trick that we pulled on statement 1, but let's still make the same kinds of columns. Pick a u, pick a v, find 1 over u plus v, and then also find 1 over u plus v. Okay, let's do it. We can still take this case. I mean, we can be lazy people. If we've done work that applies, then we might as well keep it. Right. So this is all. I mean, if you have work for statement 1 that also applies to statement 2, then it still applies. And with testing cases, that actually happens a lot. Because I mean, any cases that happen to satisfy the other statement, you can keep. Then you can use them again. It's pretty nice. So we can import that from statement 1. Now our only goal in life is to try to get that to happen, because we got this. Well, let's try. I mean, you can't use negatives. You can't use 0. So as far as special kinds of numbers, you might think fractions. Anthony's thinking fractions. You might also think extremes. Okay, let's try fractions. 1. I mean, let's just go for broke and call it 1 over 100. I'm not sure. So 1 over u plus v is 1 over very close to 1. So it's 1 over a little bit more than 1. So that's a little bit less than 1. That's good. Text is getting big. Let me make it smaller. All right, 1 over a little more than 1 is a little bit less than 1. But the right-hand side here is going to be, let me add a couple more places to that column. 1 over u is already 1, and then v is positive. So it's going to be bigger. It's 1 plus positive. So this is still less than. Okay, that didn't work. Let's try extreme numbers, extreme numbers, like, you know, big, huge, small things, etc. If u is like, I don't know, 1,000 and v is, you could, we tried u big and v small. Let's try u small and v big. Let's see what happens. Let's see if u is 1 over 100 and v is like 1. Then this is still a little less than 1. But then, oh, 1 over u is gigantic. 1 over u is 100 already. Plus 1. No way. I mean, after enough cases that you try, you might start. I mean, if you're running on a time here, you can just say, you know what, I give up. Or, I said that equation would be true, like this one here, this other condition. So meaning that we don't, I mean, I'm responding to the text box right now. Like, we know that if u and v are both positive, we know that that is true. Meaning that we don't need to expend any extra thought making this true, but not bad. This is not super obvious or anything. So, but eventually you're not gonna get it. I mean, if you keep plugging in cases, just try it. I mean, try as many cases as you can in a reasonable amount of time. Keep trying cases, you won't get greater than or equal to. It's not a thing. I mean, as far as why this actually works, it works because, I mean, let me take this on to the next page and let's talk about why. So in statement 2, this is the inequality that you're trying to do. I mean, why statement 2 works. It works because u and v are both positive. So therefore, this is going to be bigger than that, right? So like 1, you can think of 1 over u plus v is 1 over a bigger number. And 1 over v is 1 over a smaller number. Because u plus v is bigger than v. So this is already, I mean, 1 over bigger is smaller, and 1 over smaller is bigger. So this actually, this number alone is already bigger than the left-hand side. So no matter what. Without even thinking about v, this is already bigger than the other side. So that's why statement 2 works. So, yeah, there it is. As far as this goes, I mean, the honest answer is no. No, it's not. I mean, it's only time consuming, blah, 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 if you don't have a goal and you're just kind of wandering around. I mean, it really doesn't take very long to do what's on this board. I mean, this is probably 20 seconds worth of plugins. This is really not much. I mean, this is not going to take you anywhere close to 2 minutes if you know what it is that you're trying to do. I mean, I spent a while talking through it. It's hard to draw fractions on an electronic whiteboard, but this is not a ton of work. So, I mean, the best way to answer this question is just to say no. But the other good answer to this question is, even if it is time-consuming. What else are you going to do? I mean, it's funny because people do this all the time. Like they try to shoot down methods when they don't have another method waiting. I mean, it's not really a very smart way of thinking about it. I mean, you should only reject methods if you actually have another method ready to go. Because, I mean, if you shoot down the only possibility, then you're not going to be able to solve the problem, guys. So, I mean, you really have to have this attitude. If there's only one thing that you can think of, you just have to do it. So, I mean, this is the one thought you should never have. I think that will take too long, so I won't try. I mean, if you want a lower score on the GMAT, this is a great way to get one. So, don't do it. Don't do it. It's not a thing. How would you could simplify it? Yeah, you could probably pull that over there to the other side. You could make common denominators. That's another possibility too. Like if you, let's try that. Let's throw that at it. Let's see what happens. Let's take this to the next page and see. So if you move 1 over u to the other side, then that's 1 over u plus v minus 1 over u. And all right, sure. Okay, that's kind of ugly. There, now it's better. All right, if you make a common denominator out of that, you're going to have to multiply by v on this one, and you're going to have to multiply, that's going to come with parentheses here, and then you're going to have to multiply by u plus v on the top and bottom of that one. So that's going to give you a common denominator of vu plus v, and then that's v minus u minus v. So it is negative u over that less than v question mark. Yeah, that's actually really, you would have to multipy by u, yes you would. I'm just seeing if you're paying attention. And it looks like you are, that's good. So that's going to be u minus v, that's just going to give you that. All right, and the bottom is this. Okay, so yeah, this is also a thing, and then if you bring in your two statements, where are they? The two statements are, that's one, that's the other. You're probably still going to have to test cases with this one. I mean, you can try it at home, but you'll probably still want to test cases here. Here, if you realize that both things are positive, then that thing is a negative fraction, because it's negative over positive. And then that's a negative quotient. And then, of course, v itself is positive. So that works. Bring v to the other side, how so? Remember, you can't divide by stuff or multiply by stuff. You need to subtract it? Yeah, you could probably do that. You'd have to multiply it by a bunch of stuff. I mean, the point is there's a million things you can try. So, I mean, the main point that I want to make here is that the people in the chat box are suggesting lots and lots and lots of things, and that's my point. My point is whatever you think to try, just do it. Don't ever think this. Don't. If you think of anything at all that you can throw at this problem, just throw it at the problem. And, just throw it at the wall and see if it sticks. This is how you win this game. I mean, this is not a game of endless deliberating before you do stuff. This is a game of doing stuff before you think too much about it. So this statement was not sufficient. This statement was sufficient. So that's choice B. B like boy. Alrighty. So yeah, you guys are full of suggestions, which is awesome. That's exactly how you want to be. I mean, and anything you think to try. When you review the problem, you should try all of those things is the point. You should try every approach you can get your hands on. Because that's how you win the game. Yep. All right. Try this problem. Remember where your answer choices are. Your answer choices are here. And here's a timer. Go for it. Okay, at this point, less than half of you have selected an answer. So remember, the GMAT doesn't allow you to not answer things, and there's a very strict time limit. So you have to develop the skill of just pick something and move on. I mean, you definitely need to become okay with picking answers that you are not 100% sure about. So go ahead and pick something, as long as it is a something. Okay, and if you have to guess, I mean, you shouldn't feel any temerity about guessing, or you shouldn't feel any, sorry, not temerity is the wrong word. You shouldn't feel any trepidation about guessing because every answer choice has been picked at least a couple of times. So people are all over the place on this thing. So let's take a look. So this is another yes/no question. So remember what you want to do with yes/no questions. Define yes and no in terms of specifics, so translate. Then translate sufficient and not sufficient. Not sufficient first. And then understand that not sufficient is the goal. Okay. Cool. Translate yes and no. Well, you have two lines. Is the product of their slopes negative? So a yes means the product of the slopes is actually negative. What does a no mean? It means the product of the slopes is anybody. What does a no mean? Product of the slopes is either 0 or positive. Yeah. Make sure you don't forget about 0 as a case. And then the next two steps are basically always the same, but you shouldn't neglect them. So not sufficient means that you can get both of the above, and sufficient means you can't get both. Stuck with one. Okay, there you go. And the goal is to try to get both of those things to happen. So you want to try to get this, and you want to try to get this. Okay, so let's do that. So product of slopes is negative is the yes, product is 0 or positive is the no. So let's put those, let's just write those underneath the statements. So product of slopes is negative, question mark. Product of slopes is 0 or positive, question mark. Same thing. The goal for each of these statements is to get both of these things to happen. And then if we have to combine the statements, we'll just write the two again, and then we'll have the same goal. So let's do it. This one's definitely going to be, I mean, we've had some Thursday sessions on coordinate geometry data sufficiencies as well. And like one of the main points that you should definitely recall is that coordinate geometry data sufficiency is primarily about visualizing the situation. Like it's very rarely, not never, answer, but it's very rarely an issue of like MX plus B traditional algebra kind of approach, because they know you've done a lot of that in school algebra. They don't want to test you on more of the same. So let's picture this. So statement 1, you have this intersection at 4, 3. So, I mean, it's probably not terribly important that those be the exact coordinates, but, it's going to be something like there. That's the intersection point. The intersecting, you could have one of the, I don't know what PRD, maybe as product. You could have one of the slopes be 0. I mean, you could have a flat line intersect a line that's not flat. There's no reason why you couldn't have that. I mean, in these statements, in fact, in statement 2, you could have that. I mean, we'll talk about it. So, and in general, what would you gain? The more important question is, what would you gain from trying to drop this? I mean, you would stand to lose if it became important, and you don't gain anything by getting rid of it, because there's no harm done if you realize that both of these things will do what you want. So no, it wouldn't be better. Okay. So the product of the x-intercepts, that means that either both x-intercepts are positive or both of them are negative. That's what it means for a product of anything to be positive. You've got 2 positives or you got 2 negatives. So one way you can do this would be to just draw 2 positive x-intercepts. Like, I don't know, there's one, and there's the other one. I got a positive slope and a negative slope, so that's a negative product of slopes. If I draw out another situation, I don't even need to worry about 2 negative intercepts, because I can do this already with 2 positive ones. Like there's one and then there's another one. Here's my 2 positive x-intercepts, and now I've got 2 positive slopes. So that's a thing. You can have that. Again, just to make sure we're on the same page here, this is 1 negative slope and 1 positive slope. So the product is negative. Here I've got 2 positive slopes. Product is positive. I mean, you could also have 2 negatives if you just drew these guys over here on this side. That would work too. So this is not sufficient. We circled them both. It's not sufficient. We got both outcomes. Okay, let's try statement 2. Product of y-intercepts is negative. Okay. And I mean, just to show that you can get a 0, we can make that one of the cases, right? If you just have to have 1 positive y-intercept and 1 negative x-intercept. So we can make one of the lines flat. There's one. I mean, there's my positive y-intercept. So let's make sure we know which line there is the axis and which line is not the axis. Those are our coordinate axes. I just need to make the other y-intercept negative. So that's doable there. So this has a 0 slope. And this line here has a 0 slope, and this line has a positive slope. So the product is 0. So that gives us this. You can also make it positive by just sort of making this guy, like taking the line that I made flat here and just making it go a little bit that way. That would work too. So, you don't have to make the 0 case, but it's a possibility. At this point, our only goal in life is to get that. All you got to do is tweak that top line just a little tiny bit. So you can take the same setup. There's your intersection point. Here's your line with a negative y-intercept. Just make your positive y-intercept dip down just a little bit. As long as you know what your goal is, it doesn't take that long, because you know what you're trying to do. If you don't know what you're trying to do, this is a black hole. It can take you forever. But if you do know what you're trying to do, it's not so bad. This is a negative slope. This is a positive slope. So, yeah, the product is negative. So you circle them both, not sufficient. So what do we do now? What happens? I mean, they're both not sufficient, so the next step is to do what? The next step is to combine them. So now we know the product of the x-intercept is positive, and the product of the y-intercept is negative. So let's take this to the next page, because we are sort of running out of space here. So here. Okay, combined. So again, let's put those things that we're trying for again. So we want product of slopes equals neg product of slopes is 0 or pos. Okay, well, so let's think about this. I mean, you have this point. Here's 4, 3. This means you either have two negative x-intercepts, the first statement does, or else two positive x-intercepts is what that statement means. Can you have two negative x-intercepts when you combine? Well, let's try that. If we try to make both x-intercepts negative, we're inevitably going to wind up looking like this. This is not going to work because those are both, I mean, if your x-intercept is over there and you have to hit this point, somewhere in there you're going to have a positive y-intercept, both of them will. So if you combine the statements, this is not possible. So that means you got to have this. All right. Well, let's try that. So the product of the x-intercepts is positive is only going to mean that we have two positive intercepts. And the product of the y-intercepts is negative. So you got to have somebody hit down here. So you got to have that. Then you got to have a positive y-intercept. Can you do that? Well, you can do this. That works. So this gives you product of slopes is negative. And we've got our two positive x-intercepts, one right there and one right there. What's our only goal in life now? I suppose besides continuing this out, so it actually looks like an intercept. What are we trying to do? Let's clear out this space over here to do it. Well, remember, we better not be thinking about yeses and nos. I couldn't handle that degree of abstraction. Like if I were thinking about yeses and nos, I would not be able to do this. You want to think specifics, guys. Just translating into specifics is really, really, really an important thing. Yeses and nos, if you guys can think on those and in that kind of abstractions, and you're a lot better at that than me. We're trying for this. We're going to see if we can get this. So, but let's see what we've got. I mean, there's a lot of information here, right? You have two positive x-intercepts. And you also have one positive y-intercept and one negative y-intercept. So, I mean, if you combine all the information, we have two positive x-intercepts, and we have one positive y-intercept and one negative one. So what that means, I mean, each of those lines has to have something like that, right? So we need one line with positive x-intercept and positive y-intercept. It's going to look like that every time. It's got to slope downward. I mean, that's the only way you can hit both positive axes, is if you have a negative slope. But the other line's got to have a positive x-intercept and a negative y-intercept. So that's going to have to hit the y-axis below and the x-axis to the right. So it's going to have to look like this. I mean, you might not realize this right away, but if you plug in enough cases, you will realize in pretty short order that you're going to have one downward sloping line and one upward sloping line. So every case that you can think of will look like this. In some sense, it'll look like that. And so you're not going to get this. This is not a thing. And you're stuck with product of slopes equals negative. This is sufficient together. So this is going to be C like cat. Any questions about this? It's a cool problem. I mean, it really, as with a lot of other data sufficiencies that have lots of words and stuff in them, it's a really good problem to test whether you're focused on the right goals. I mean, if you're not trying to accomplish what you need to try to accomplish, then this is going to take forever. But if you are, then it's not so horrible. It'll still take longer than most problems, but nothing that you can't handle. So, all right, someone's typing. Two people are typing. C. I don't actually know what C means. I'm assuming M's are slopes, but I actually don't know what C is. So, if you've come to more than one or two of my study halls, then you'll know that I don't answer questions about difficulty level, because answering such questions would be pointless. I mean, as a test taker, you should never think about that. There's no sense in thinking about it. I mean, you can't tell, so why bother thinking about it? It's just going to distract you from solving the problem. The whole world is you and the problem. If you let anything else into that world, it will not have good results, it'll have bad results. Okay, let's see. Yeah, it's possible that you can do it algebraically. I don't doubt it. Visual is usually more efficient, almost always more efficient. But more ways is better. If you've got an algebraic way to do it, then you should let it rip. Okay, what about that one? Right there. Give that a shot. Give you a timer. Here's a timer. Have fun with that. Okay. This one must be a party because we only have 11 answers out of 31 of you guys. So, pick something. And at least while you guys are filling in your answers, at least you do as a group seem to have realized that, I mean, this right here is not sufficient. We got one person with D. That might just be a random letter that someone picked, or it might be like confusing D with C. But this is not sufficient because you just don't know. C could be anywhere. But just make sure we're on the same page with this. So a yes to this means C is between A and B. A no, we might as well just go with C is not between A and B. I mean, that could happen in so many ways that there's not really much point in listing them all out. I mean, you could have C equal A or B. You could also have C be less than A. You could also have C be greater than B. So, right. Also, notice what else we don't know here. I mean, we don't know a lot of things. Like C could be anywhere right now. But also, what else could be anywhere, which would be significant? Yeah, the zero, because the zero is the signs. I mean, these numbers could have any signs at all. Right? They could be two positives, they could be two negatives, they could be A negative, B positive, one of them could be zero. We don't know, right? So, but statement 1 is not sufficient because there are no restrictions on C. So, you can definitely put it either between A and B or not. So that's gone, which means we could dedicate a lot of time to thinking about statement 2 and or both of them together. So let's talk about statement 2 first. So A minus B is greater than C. And that still gives us a lot of things that we can try. I mean, one thing you'll notice, and even if you don't notice it right away, after you test just a couple of cases, you definitely will notice it, is that A minus B is going to be negative because A is less than B. But let's just pick numbers that do that. As far as how to get the numbers, you might as well just pick an A and a B and then just pick C's that make this happen. So let's just A, B, C, and then is C between A and B, question mark. All right, well, let's just say, I don't know, A is 1 and B is 2. Because remember, your first case can be random. I mean, you don't really have to try for one of these until you get the other one. So how do you know? Well, it's a number line, and A is to the left of B. So B is definitely bigger than A. Because number lines always go from left to right. So the B is bigger than A. That's kind of the only thing we know right now at all, is that B is bigger than A. So is C between A and B? I mean, A is always less than B because it's to the left of it. I mean, left to the left of is the same thing as less than. So let's see. Is C between A and B? So that's just the two things we're trying to get. Okay. Well, if no such insight comes to mind, then you should just throw the cases in there. I mean, you definitely won't do yourself any favors by looking for insights. I mean, if insights pop into your head, that's great, but you don't want to search for them. I mean, if you don't have a light bulb, then you can just grind it. There's a lot more grinding than light bulbs on this test anyway. Okay, so A minus B, I mean, let's actually make another column for A minus B too, because that'll make it easier to pick C. So A minus B is -1, and we need that to be greater than C. So if C is like -2, then C is not between A and B. Okay, so there. Our only goal in life is to try to put C between A and B. Well, what you can probably tell is that if you can't tell, you can just throw positives in there and watch. But if you have positive numbers here, then that's going to be negative, and C will have to be even more negative. So 2 positive numbers isn't really going to keep doing what we want. So let's try 2 negative numbers. Let's try -2 and -1. So then A minus B is also minus 1. C has to be something less than minus 1. So we can get it to be between A and B by making it minus 1.5. I mean, you wouldn't happen upon that value at random, but if you understand that your goal is to get this case that you did not previously get, then you'll definitely come up with something like that. Might not be the exact numbers that I have, but you'll come up with something. So not sufficient. Okay, so what do we have to do? We have to... The two statements are not sufficient, so we have to do what? So we want to combine them, right? So to eliminate C. If you mean that you mean that we should try C versus E, hopefully is what you mean. And we can't just cross out C right now, but we have to, yeah, we have to try them together. So combine. So again, in the interest of being lazy, if you have cases that work, then you should keep them. So we can't keep the top case, but we can keep the bottom case. So, because that has both statements satisfied. B is less than 0, and A minus B is indeed less than C. So, and then let's put our goals, because we have the same two goals again. C is between A and B, question mark. And C not between A and B, question mark. So we just got it to be between them. I mean, we don't have to look very far to get it to be not between them. Because again, notice that you can keep these values of A and B and A minus B. Because C can be absolutely any number on the planet that is less than this value of A minus B. I mean, it can be anything at all that's less than minus 1. So if you have, just pick something that's below minus 2, yeah, minus 1,000, they're not between A and B. Done. Got both. Still not sufficient. It's E. So there you go. B minus A is, and you, let's see. I mean, let's see, DDDA, you're rearranging these things. You're switching the sign. That is valid math. I don't see right away how that's going to help you answer the question of whether C is between A and B. Because it looks like you've got a distance between A and B and then totally separately a distance between 0 and C. So the problem is that those don't, I mean, you don't have C interacting with A and B really in that inequality that you're using. Like you're thinking about a distance between C and 0, but I mean, maybe there's a connection I'm not seeing right now, but I don't see how that relates to this question. But if it helps you pick cases, then by all means, go for it. A lot of people see connections that I don't see. I don't see the connection, but if you do, then go for it. Other questions about this problem? Again, notice another one of those problems that can take forever and ever and ever, amen, if you don't have a goal. But if you do, if you know what it is that you're trying to accomplish, it's really not so bad. Alrighty. Let's look at, get at least one more here. Let's find one. Let's Find a good one. How about this? Right here. This is not everyone's favorite problem in the world, but go for it. All right. Here's a timer. All right, let's pick something. And now I bet you're another student called DDDA kind of raised that exact point, and I spent about a whole minute responding to it. So maybe just check out the recording or something. I mean, the short answer is I don't see how you would connect that to the location of point C, because the distance between A and B doesn't tell you what their coordinates are. But the more important point is if you try that approach and it doesn't really do anything for you within 10 or 15 seconds, if it doesn't give you some meaningful insight, you shouldn't keep hacking at it. You should just plug it in cases, because, we'll talk about this problem on the board in a second, but I mean, the most important point to make about this is you don't need any insights about the problem at all to do this. But this is the whole looking for insights thing. The entire point of testing cases is that it lets you do this without insights. That's actually why it's a good method. If you have this whole dichotomy for data sufficiency problem, right? I mean, the whole reason why testing cases is so awesome is that this whole thing that's here on the left generally needs insight, as you guys are calling it. But testing cases doesn't really. I mean, you can, a lot of the time, you can do this successfully with absolutely no real insights in the problem. I mean, that's the point, right? You really, honestly, don't bank too much on having brilliant realizations. I mean, the reason why they put problems like this on the test is because just grinding out cases has much more potential than searching everywhere for brilliant moments. I mean, really. I mean, you can just grind out numbers. So, but what you're writing in the window just kind of seems like stubbornness. I mean, I don't mean to be a jerk, but if you would rather try to search for random moments of brilliance than to trust yourself to do simple arithmetic, then that doesn't seem like the right priorities to me. Seems like you should practice simple arithmetic if you're afraid of making mistakes at it. So, okay, let's go back to the problem that we were looking at. Let's go back to this problem here. All right, there, that problem. Okay, let's talk about it. So is R over S an integer? It's another yes-no question. So yes, it means that R over S is an integer. What does this also mean? If you can divide two numbers and get an integer, what's it the same thing as saying? If the quotient of two numbers is an integer. Yeah, it means that S goes into R evenly. So same as saying R is a multiple of S. And no is R over S is not an integer, which is the same as saying that R is not a multiple of S. Okay. So that's what we want. So let's, statement one, so R is a multiple of S, question mark, and then R is not a multiple of S, question Statement 2, same two things. Let's try for these. Okay. See if we can get these to happen. Statement 1, every factor of S is also a factor of R. So, I mean, if you might just abstractly realize what's going on here, but if you don't, then all you got to do is find a couple of cases and you'll see what's going on. So you want to find S first, and then try to pick some R, and then there you go. Well, let's try S. Let's start with some small numbers. Let's say S is 2. Okay. So if S is 2, then the factors are 1 and 2. Oh, look at that. Well, I mean, that means that 2 has to be a factor of R. So it's going to be some multiple of 2. Because it has to have 2 as a factor. Okay, well, if we try another number, it's going to, you'll see right away. Like if we try 6, the factors of 6 are 1, 2, 3, and 6. But every single time, you're going to have S as a factor of itself. So even if you didn't realize this in abstract terms, like as soon as you start throwing numbers at it, you'll realize. Like whatever S is, that S is a factor of itself. And I mean, if you realize that abstractly, of course, then that's great. If not, when you throw specifics at it, you'll realize, I mean, S is a factor of itself. So, according to the statement, S is a factor of R. Always a multiple. I mean, the point here is that you could realize this abstractly if you have that kind of insight. But if you don't have the insight, as was the point I was making about the other problem, that's where testing cases is most brilliant, is when you really don't have amazing insight. And you're really not doing much other than just kind of like looking at it. And you can just throw stuff at the wall and see if it sticks to the wall. So statement 1 is sufficient. We need inside. I don't know what that means. Perhaps you can explain. We need inside. Inside the room? Inside, I don't know. Okay, anyway, statement 2. Alright. It's a joke that I don't get. Slow day today. Statement 2, this is just prime factors this time. So, let's try to make this happen. Well, it should be pretty clear that you can get R over S to be an integer. So, I mean, you can get R to be a multiple of S pretty easily. So if we do the circling and crossing stuff out here, on statement 1 we circle that and we cross that out. First thing's possible, second thing isn't. Let's try to do it in statement 2. So getting the first case is not so bad. I mean, you can just make S and R the same number. So, like if S is, I don't know, like 10, and R is also 10, then sure. Because every prime factor of 10 is definitely also a prime factor of 10. So we got this. How are we going to get this to not work? How are we going to get it to not be a multiple? Yeah, what you can realize here is that prime factors don't necessarily include, they don't include when you have like repeated instances of that prime. Like for example, if you have 5, then the only prime factor of 5 is 5. But if you have 25 or 125 or anything like that, the only prime factor is still 5. So here, if we let S be, say, 5 and R is 25, the only prime factor of each is 5. That's still a multiple, but if you switch it around, it still works, unlike last time. Because last time we would have had to, this wouldn't have worked in the other statement, because we would have had to consider 25 also as a factor of R, but not this time. So here, still 5 is the only prime factor of each, and 5 is not a multiple of 25. So we got it to happen. So this is going to be not sufficient. So yeah, you could also, you could do something like 6 and 12, where this time you have the prime factor 2 that repeats, that plays kind of the same role as a 5 does in this example that we've got here. So absolutely, yeah. So cool. All right. Any questions about this? So probably the most important takeaway from these problems is what you should be doing when someone puts a yes/no data sufficiency in front of you. And you should look at it and translate. Can you explain why it is not sufficient? Jay, all this whole thing is an explanation of why it's not sufficient. So you got to tell me what you don't understand that's there, because otherwise I would have to go over like all of this again from scratch. So it's your job here is to tell me what you don't understand, and then we can address it. What would be the multiples of the prime factors would be, it sounds like it would just be statement 1. I mean, because factors of a number include all the possible ways that you can multiply those prime factors together. And so, Brian, in response to your question, I think that the words would just be statement 1. It would just be exactly what statement 1 says. So, yeah. Okay, so Jay is not typing, but again, Jay, that's not a question I can answer unless I know what it is that you're having trouble with. Like which specific part of this is the issue. All right, well, let's see, we got about 1 minute until the scheduled closing time, so we might as well just kill it 1 minute early here. So, thank you for attending. I do believe the next study hall is in 2 weeks. And the times are a little bit shifty over the next couple of months, because I'm also teaching an online class at around the same kind of time frame. So make sure you double check the times of these things. I think it's going to shift to a bit earlier starting next time. I want to say 6 p.m. Eastern instead of 7 or 8. But just double check it, and we'll go from there. In terms of when, I mean, we try to do some verbal, some math. If you look over the archives, it's about an even split. But I don't even know what we're going to do in any given study hall until about half an hour before it starts. So, because these are not planned things. It's free product. You kind of just do it ad hoc. The archives, there's only one web page of Thursdays with Ron. You just go to it and you scroll down, and there are the archives. Just scroll down and you'll find them. Okay, that's it. So I'm going to stop the recording. Good night and good luck.